Hey guys, today I'm going to solve a 1410 rated problem, Bella Ciao. So originally I was planning to try a 1425-26 rated problem. So I opened it and I was like, what the heck is this? Nah, not today. Let's step down a little. So yeah, we are doing Bella Ciao today. Let's look at the problem. Alright, Bella Ciao. Chef is planning a heist in the Reserve Bank of Chefland. Okay. They are planning to hijack the bank for D days and print the money. The initial rate of printing the currency is P dollar per day, and they increase the production by Q dollars after every interval of D days. For example, after D days, the rate is P plus Q dollars. After 2 D days, the rate is P plus 2Q dollars, and so on. Output the amount of money they will be able to print in the given period. Okay. Inputs, the first line contains number of test cases, the second line contains four integers, capital D, small d, p and q. Okay. So I did some calculation here. Ignore the messy part and just look at this section. Here are a couple of examples I have tried. In the first example, for the first interval, the rate is 1 because p is 1. Then for second interval, the rate is 3 because we are adding p plus q. Then in the third interval, we have p plus 2q. Then fourth interval, we have p plus 3q and so on. Similarly, for 5 to 5, 3 we have p, then p plus q, then p plus 2q. So you can clearly see we are adding a fixed increment in every interval. Every d days the rate increases by q. In the first example, q is 2, so the rate is increasing by 2. In the second example, q is 3, so the rate is increasing by 3. This is basically an arithmetic progression. The rate is changing every interval and we are multiplying that rate by d days each time. So we can get the total number of intervals n by dividing capital D by small d. And for every small intervals, we can calculate the amount printed as d multiplied by p plus I into q. Here I is the interval number from 0 to n. Now at the end we might have a few leftover days. For example, if capital D is 3 and small d is 2, then we will have one leftover day. And for those, we just multiply the remaining days with the last rate. So it would be p plus n multiplied by q multiplied by remaining days. Now let's put it into code. Alright, I've taken all the inputs. Now we will have n for number of intervals. Then we will have r for remaining days. Then we will have sum. For loop I equal to 0, I less than n, I plus plus. Now rate equal to p plus I multiplied by q. Now sum plus equal to d multiplied by rate. Okay, now for remaining days, we will do sum plus equal to r multiplied by p plus n multiplied by q. All right, let's print it. All right, now let's test it. 3, 4, 13. It works. Let's submit our code. All right. Oh, package. Done. Okay, let's submit. So I realized there was a bug in my code. Instead of doing capital D modulo small d, I was doing D modulo 2. So I fixed it, but I'm still getting time limit exceeded error. So it looks like instead of using loop based approach, we will have to use arithmetic progression formulas. So this is our expression. You can see that P is fixed and we have a growing multiple of Q from 0 to n minus 1. So we can break it down to D times n multiplied by P plus Q multiplied by sum of integers from 0 to n minus 1. Now we know the formula for sum of n minus 1 natural numbers, that is n into n minus 1 divided by 2. And if you simplify this, we will get d multiplied by n by 2 multiplied by 2p plus n minus 1 multiplied by q. Let's put this into code. Alright, I have put the formula here. Let's submit the code. So I'm still getting time limit exceeded. Maybe let's use buffered reader instead of scanner. All right, I've used buffered reader now. Let's submit the code. So I'm getting wrong answer. I checked the formula again and it should work. So I think it's because we are using int. Let's try with long. All right, let's submit again. And it worked. So the problem was with scanner and not with the for loop. So maybe it could have worked with for loop as well. I will have to try that later on my own. But yeah, this was a good problem. I liked it. It was quite challenging. I'll probably stick to this 1400 difficulty level for a while. Not sure if I'll make a video for every problem though. But if you want me to, just let me know. Alright, I'll see you guys next time. Bye.